So in this particular video, we're going to be working on POD10, and so there are two problems that I picked out from this POD that I'm going to work for now, and I'll pick a couple of others later. So this deals with solutions and how things dissolve into different types of solvents. So before we move on into doing this problem, I want to just go back and just remind you that in order to solve these types of problems, you need to first be able to draw Lewis structures or understand how to determine the polarity of a substance. And so polarity is key. And one of the things that I teach in my lecture is that light dissolves light. So if you're polar, you're going to dissolve into a polar solvent. If you are non-polar, you're dissolved into a non-polar solvent. Now, normally water is a very common solvent that we use. We use it every day in our lives, of course. And then carbon tetrachloride, in this example for problem 1, carbon tetrachloride is another type of solvent, which if you draw the Lewis structure, you have carbon and 4 chlorines around it, which creates a non-polar substance. So there are many different solvents out there. Hexane is another very common solvent, and hexane would be considered a non-polar substance itself. Now, in this particular problem, what we're looking at is trying to figure out which is going to give a more concentrated solution, being that you dissolve stearic acid in water and carbon tetrachloride. So the formula is given to you here, and what we see from the formula is that you have 1 carbon and then 16 more carbon hydrogens added into the chain. So this is a very large compound in itself, and it's composed of mostly carbon hydrogen. Now that in itself creates a nonpolar substance. Now on the very end of it, you have this carboxylic acid functional group, which is going to give you your C double bond O with an OH, and then you have the other rest of the chain. So this portion here is going to present a polar section on this compound. Now, as we look at the structure of this compound, stearic acid, we have to understand that it's composed of mostly carbon hydrogen, and it's a bunch of them, and then you end it with this double bond oxygen with the OH group. So this compound is majority going to be nonpolar. Now, in saying that, that should answer the question as to what's going to give a more concentrated solution. Well, if you dissolve it into the carbon tetrachloride, it's going to dissolve more into carbon tetrachloride, which is going to create a higher concentration. And that all goes back to the fact that you have this long carbon hydrogen chain, which creates a much more nonpolar substance than the polar functional group that you find on the end of the carbon chain. So again, it all boils down to just understanding the different parts of these structures and knowing whether they're polar or nonpolar, or if they're both, which is going to be the dominant part to that structure's intermolecular forces. So again, if we were to discuss intermolecular forces, which is not part of the problem, but it is important, London dispersion forces are going to be the dominant force here, which is what carbon tetrachloride has, and that's the only force that carbon tetrachloride has, because it's a nonpolar substance. Now in part B, it says, why is glycerol extremely soluble in water? Well, glycerol is composed of 3 carbons, and then there are alcohol groups on each of those carbons. That creates a much more polar substance. There's a lot of hydrogen bonding taking place. Water itself is polar. Going back to what I said at the beginning of this video, light dissolves light, so water being polar and glycerol being polar, that's why the two dissolve into each other very efficiently. And They're very miscible in this case. So why is glycerol extremely soluble? It's because there's a lot of hydrogen bonding. It's a very polar substance, and polar dissolves in polar solvents. Alright, so again, we'll come back to the other problems that are found in POD10 in the upcoming video. For now, just continuing on with what we have been discussing in the other problem sets with intermolecular forces, Lewis structures. All this starts to tie together in understanding solutions and how solutions are formed. Thanks for watching.